I've taught A-level maths enough times to know that about half the trouble could be avoided if everyone always remembered this, and this. Questions like this fall apart under difference of two squares. Here, it's the first critical step. You can even get through the technical side of a Cambridge Maths interview question with only these three identities, but they've got to be secure. So come on, find some paper, a pen, and let's get you sorted before September. Hello, here's the plan. I'll go through some questions explaining what's going on in what I hope is a helpful amount of detail, pointing out what I think is worth knowing. If you'd like to pause, that might be helpful, but don't worry, as I'll say when it's important to have a go yourself. The difference is, unlike a teacher, I don't know who you are, so it's difficult for me to allocate a set amount of time for you to do the questions, and I don't want people to be bored while I'm waiting. But otherwise, I will get started. First question. Factorise x to the 9 minus x. This looks like a fairly simple question, but it's quite revealing because a lot of people just write down x brackets x to the 8 minus 1. And that is a factorisation, but it's not a full factorisation. We can go much further. And the thing you need to realise is that x to the power of 8 is actually equal to x to the power of 4 squared. And so this becomes a difference of two squares. So you can write x brackets x to the 4 minus 1. Don't forget 1 is a square number, 1 times 1. X to the 4 plus 1. And again, we're not finished. We can go further. X to the 4 is also x squared squared. So we can factorise this again using difference of two squares. And then one more time, we can keep going. There we go. And we get there. So it's a bit of a faff to get to the answer, but it's worthwhile thinking about that and making sure that you are on board with this. Not literally, like I was earlier. Next one. Now this is a classic. So many times people say, oh, x equals 1, and you just divide it by x. Well, 1 is a solution, but it's not the only solution. And so for questions like this, what you need to do really is subtract the x squared the x onto the left-hand side and then factorize it like normal. And this is quite straightforward. It's just x, common factor, x minus 1 equals 0. And then we can solve this. So x equals 0 or 1. And then those are your two solutions. Now, when you divide anything by 0, you get into lots of trouble. So when you divide by x, in this case, you're doing something that you're effectively not allowed to do. So always put the terms onto the left-hand side, factorise, and then solve. Factorise this quadratic. Now, it looks fairly straightforward. It's just a quadratic, but I would never try and factorise that directly. If you do, it's difficult because I've never really practiced factorising things with negative x squared terms. It's just unfamiliar. So it's worth getting this into a form that's easier to work with. And the way I do this is I would take out a minus sign. And now this is easy. This is familiar. This is a nice quadratic. And we can just factorise this. What is it? Probably find I can't do it now. So you have 3 and 1, and it's minus 3, and it's plus 1. Now, I will show you quickly what some people do, and this really pains me. And this is not good. This is simply not equal. It's like saying A equals minus A. It's absurd. I call it countdown maths, where you often get sort of 3 plus 5 equals 8, plus 2 equals blah, blah, blah. And it's like saying 3 plus 5 equals 8 plus 2. No. You see what I mean? Right, let's go on to some fractions. And how are you going to do that? The nonsensible thing to do is think, oh, the denominators are different, so I know I'll cross multiply. I'll multiply this by x minus y over x minus y, and I'll multiply this by y minus x over y minus x. Now that's not wrong, and you can still get to the answer. But consider that a over b equals minus a over minus b. Very important. And then this now becomes x over x minus y minus y over x minus y. And then it's really straightforward because it's just x minus y over x minus y. And then that's just 1. Okay, now slightly harder. And in this one, it's the same idea. Do you have a go at it yourself, I would suggest, but otherwise I'm going to go through it now. And this time you add them together. So we actually get x plus y over x squared minus y squared when we change that sign. But now we're not done because you should recognize on the denominator we have a difference of 2 squares. So this is x plus y over x plus y brackets x minus y. And so we can cancel those to get 1 over x minus y. Now, if you want a much harder one, I'm not going to go through it now because it would be a little bit laborious, but I will post the answer at the end, and it's here. Okay, it's actually not too hard, but have a go if you'd like. Now, on the subject of fractions, this next one is really important, actually. This one I think deserves a video in its own right. It's such an important trick you can use. What a lot of people do is they try to combine the denominator into one fraction. And so you make this x over x minus 1 over x, and then you combine that into x minus 1 over x. But then you end up having 1 divided by a big fraction, and that gets a bit messy. I mean, think about this. Are these two things even the same? 1 over a over b, does that equal 1 over a over b? And to make that clear, I'll put brackets around. Are those two things the same? Now, have a think about this. Do pause it and resume when you think you know the answer. Okay, it turns out they're not the same. And this one here on the left-hand side is actually b over a, because when you divide by a fraction, you're already multiplying by its reciprocal, whereas this one is actually 1 over a b. Okay, so these are very different things. And if you're simplifying fractions like this and writing them as fractions over fractions, it gets very, very messy and a little bit ambiguous sometimes. So there's another way you can do this really, really quickly, and that is to just times it by x over x. And this really speeds up the simplification because the numerator becomes x and the denominator just becomes x minus 1. And now that is done. That's in a much nicer form. Really, really easy. Another example quickly, just to show you what we should do. And like before, we don't want to combine this, but we want to multiply by the denominator here. And that way you get rid of the fraction within a fraction. So you times it by x minus 1 over x minus 1. And this becomes quite simply this. And then, if you want to, you could multiply out the top, but I don't think you need to particularly. X minus 1. You never know, you sometimes get cancellations, so it's useful to keep the top factorized. And so we get 7x minus 7 minus 5, that's minus 12. It's not particularly pretty, but it's certainly a lot nicer than this. Okay? Really easy technique. I really like these questions, and I once got a bit carried away. I was teaching a year 10, I think year 10 class, maybe year 11, and they were a very good class, so I was able to give them quite hard questions. I got really carried away, ended up giving them something like this. And I think they thought at the end, what the hell is he doing? But I do think this is a useful skill to have. This sort of thing comes up all the time. You might be doing some sort of substitution in an integration, and this sort of thing can come up. And it really, really helps if you can simplify these quickly and efficiently. Okay, here we are. And just have a look at this. I really suggest that you do actually have a go at this yourself. But if you just want to watch, I guess that's still slightly helpful. So I'll just talk about it now. It's very tempting to multiply this out, and it's tempting to multiply this out, and you can do that, but it's a lot of work. And instead, when questions like this come up, you want to be thinking, how can we be a bit more efficient? And this is a quadratic which we can factorize, and it's not too difficult. It's just x plus 7, x plus 1, and got a squared here, and I'll just make it really clear what's going on. This is what we have. Okay, and just remember with rules of powers that if you have ab squared, that's a squared b squared. So this is actually x plus 7 squared, x plus 1 squared. And there's no need to multiply anything out. And now here, you might be tempted to cancel out the x plus 7s. And you could do that, but a bit like before, you will miss out some of the solutions. So instead, we keep it all together and we put it onto the left-hand side and then see what happens. So just do one step at a time. Don't do anything dramatic. Don't try and solve it in one go. Just keep it all together. So just remember the basics of factorizing. If you've got a common factor, use that first. And we do. So x plus 7 squared, in fact, that's the highest common factor. And now use square brackets because we're doing brackets within brackets. X plus 1 squared minus x plus 7. Now I like to put that in brackets again, just to make it absolutely clear what I'm doing. And it's just much less work, cognitively speaking. And now we can simplify this thing. So we've got x plus 7 squared. And then we can do the multiplication. X squared plus 2x plus 1 minus x minus 7. And again, you don't want to do that in one step. Just do it gradually. And then here we are with another quadratic. And we've got 6, and that looks like it's doable. So let's factorize it. And then here we are, and the sun has come out, and the answer is in front of us. So we have x is minus 7, 2, and minus 3. Okay? So I hope that was helpful, pointing out some fairly random things that you may have forgotten or may not have known. And it's just a sort of taster for what can come next. I will explore some of these topics in more detail in subsequent videos. Otherwise, if you enjoyed this, do give it a like or a subscribe, whatever it is people do. What did I learn in this video? That I am terrible at rowing and terrible at remembering my lines. As you can see here, enjoy the butterflies. Goodbye. So come on, find a pen, a paper, and let's get you sorted before September.